So what we have on the screen is the profile geometry that we want to nest, and then we have a rectangle for the nested sheet. The geometry has to be outside of your sheet. It can't be located inside. That will interfere with the nesting algorithm. So we got the geometry located over here on the left side. We have a rectangle for your nested sheet. You don't have to draw the rectangle. If you don't draw a rectangle, you can just enter the dimensions and it'll be placed, the geometry will be created from the world origin in Rhino. So the first thing we want to do is obviously go up, if you don't have the profile nest module running, and I have the mill module, so I'm going to go up here to the profile nest module. And let's make this a little bit wider so we can see all the menus at the top. And we have one tool already defined for us, a 1/2 inch flat mill. And very similar to our milling module, you will start from the left to the right and work your way through the menus here to create your final nested sheets. So in the machine option, there's really nothing to select here other than your, the extents of your machine envelope. For profile nesting, your number of axis will be set to 3, and that's the only option you have. Both 2 and 3 axis machining is defined with a 3-axis machine type. So the next option is to post. The same in all of our modules. You can select the post that you want to use. And let's see, we're just going to create a CNC Masters Inch just as an example post. And all of this is exactly the same as our current module. You can edit your posts, you can define the location of your post, etc. So we have our post defined. Now, the next option in the tree is the stock menu, but the next option up here on the nesting tab is to define your sheet. So we're going to select that. So as we mentioned in the presentation, we have a select sheets dialog where you can define the characteristics of the sheet. What you're doing here is you're defining one sheet size. So all the sheets will be the same size as they're defined here, and you can add another sheet if you have different thicknesses in your parts. We will need to have a sheet for each thickness. But for our example, we just have 2D drawings. So we're going to go ahead. We have a rectangle on the screen, but we're going to show you how to actually define the dimensions as well. So we're going to go and we're going to set the length to 96. We're working in inches, and select the height to 48 inches and the thickness to 1/4 of an inch. And then want to pick the add sheets, and you'll see that a sheet was added to the list and is highlighted on the screen. So our parts, they're all just laid flat on the XY plane, so we only need one sheet defined. We're going to pick OK. So now you see that the sheet is defined in blue and there's nothing inside it. That's the way you want when you start out. So let's go ahead and talk about stock. You have 2 options for defining your stock. You can define a stock box or a part stock box. The one you want to use is just a simple box stock. So we're going to display the stock dialog, and you basically give the dimensions of your sheet. If you typically, I already defined this stock. If when you do it from scratch, you won't have any dimensions in here. Just put your stock dimensions the same as you had for your sheet, the height, and for the origin location, you can use the pick button and just locate your 000 origin in Rhino as your starting coordinate for the stock box. So we're going to pick OK there. And let's just take a quick view of our geometry. You'll see that we have the 2D geometry over here, and then we have our stock oriented on top of our rectangular geometry that defines the sheet. Go back to our top view here. Now, if, for example, you had you created your stock and it wasn't aligned already, you can go ahead and use the align option, and that will allow you to align your stock to your geometry. So we already have it aligned. We don't need this. We're going to go ahead and cancel out of that. And then also for material. Now, when we talk about material, let's just stop a second and talk about how this works. So what you're doing is typically you're laying out your parts on a flat sheet of material. You're only working with profiles, so this is used primarily for cutting patterns. You can cut, like if you had patterns, whatever, of leather, or laminate, whatever, that you want to lay these patterns out on and then cut them out. And then you can define your stock from here. Typically, you can just go ahead and set this to anything really at this point. We're just going to set it to wood for now, and we'll pick OK. So now we've defined the machine setup, the stock, the alignment, and the material. And then also, if you want to define a work zero, you can. By default, the work zero will be at, like I mentioned, the world origin in your CAD file. This is your origin by default. So we don't really need a work zero unless you wanted to locate your origin somewhere else on your sheet, at the top of your sheet or in another corner. But typically in most cases, it'll always be the bottom left corner of the sheet. Go back to the top view. Okay, so we did the machine setup, the stock, we talked about the work zero. Now let's talk about the nesting parameters that we mentioned in the presentation. So how do you want these profiling operations defined, located in the sheet? You can define an orientation angle. The parts can be rotated to get the best fit on the sheet. We have that set to 90 degrees, so we could turn 90 degrees, from the x-axis, up to the y-axis, depending on how they want to fit it on the sheet. And again, we mentioned you can, if your parts profiles are large enough, you can put parts inside of other parts. You can also define the distance. We have the distance between parts set to 1/4 of an inch. And again, that's the distance between the profiling operations. The center point of the toolpath, from that center point of one profile to the next center point of the next profile is going to be 1/4 of an inch. And then also we have 1/4 of an inch set between the outer profiles and the outer dimensions of the sheet itself. And we got the accuracy set to high. We're not going to go ahead and tag these. You can select this if you want to automatically place tags on each of your nested profiles. And then also you can define how you want the sheets laid out. If you want them all laid out along the x-axis or along the y-axis, typically I just leave it set to stacked, and they'll all be at the world origin on top of each other on different layers. So let's go ahead, and you can also estimate your number of sheets and execute the nest. Before we do this, we want to go back in and actually set our profiling operations. So let's go ahead and do that. So as we mentioned before, all of the parameters for creating your profiles is exactly the same as the profiling 2.5 axis profiling operation in the milling module. The added options or parameters for nesting are located up in the nesting parameters section. But let's go ahead and start with our control geometry. And we're going to be profiling these pieces of geometry right here. So each each operation is going to be one nested profile. So we're going to create a 2.5 axis operation for each of these parts. So we're going to go ahead and pick the select curve edge regions option, and we're just going to window select this part, and we have our parts defined here, and we have our flat mill, half inch flat mill defined. Feeds and speeds, we're picking those up from the tool. Clearance plane, this is all the same as in the milling module. We'll leave it set to automatic and cut transfer to the clearance plane. For the cut parameters, we'll set the tolerance to 1 thou, and we'll leave zero stock. So we're going to be making one pass to cut these patterns out on each of our sheets. And we'll use a mixed cut direction. And for the cut start point, we'll leave it set to longest side, so it'll decide which side to actually have the start cut point. Now, one thing you may want to be aware of, and when we get to the entry and exit tab, I'll show you that in a moment. And then the cutting side, you can specify those based on the 3D geometry, or you can tell it whether to use the inside and outside. So our part, we're going to cut on the outside of the parts, but we have nested holes inside of our parts. So we're going to use this option, alternate using nesting. So it's going to start on the outside, and then any inside profiles, it's going to cut on the inside. And as I mentioned before, the step over, we're going to leave this set to 0. We're going to be making one pass around our profile geometry. So for the cut levels, we mentioned when we defined our sheet, the depth of our sheet is 1/4 inch. And where is our geometry located? It is located on the XY plane. If you look at the front view, you will see that the geometry is aligned with the bottom XY plane in your world origin. So let's go back up to here, and let's bring that back. Let's go to the top view. So your depth of cut, the location of cut geometry. Your geometry is located on the XY plane, so that's going to be the bottom of your cut. So we're going to pick at bottom, so the cutter will stop on the XY plane. So what is the total cut depth? We set our stock to 1/4 inch. So we're going to make this 1/4 inch. If you want to cut a smidgen amount deeper to make sure you cut all the way through, you can set this to say 0.255, say 5 thousandths below the XY plane. Well, actually, let me back up. That's not correct. If you have your geometry set to at bottom, the total cut depth will always be at the bottom. Sorry about that. If you want to actually go past the bottom, you would use the pick top, and define the top of your stock, and then the depth would go below the XY plane. But for now, we're just going to leave it at the bottom. We're going to stop at the bottom, going down 1/4 inch. And we're going to leave the rough depth per cut set to 1/4 inch, and the rough depth set to 1/4 inch, the finished depth set to 0. So we won't have a finished depth. We're just going to have one pass around each of our profiles, and it's going to be 1/4 inch deep. And then you can define your cut level ordering, whether you want to cut all the way to your depth on each profile segment. This really isn't going to come into play because we only have one pass, one cut level that we're cutting. So I mentioned on the entry and exit. Any entry and exit that you apply to the profiling operation is going to be considered in your nest. So if you have linear or radial entries or exits coming out on your profiles, your profile is going to be considered all the way out to this point, because it's going to be part of the operation. So typically, if you want to get as tight a nest as possible, set that to a long path. So it'll be a ramp entry around each of your profiles. So your part will not extend, your profile will not extend out past the perimeter of the part itself. And then you can define the height of the path, the ramping angle. We got it set to 10 degrees, and then the height of 50 thousandths above our material. So in the exit motion, you don't have a ramping exit. You just have lines and arcs and none. So we're going to set it to none. But you can, since we have only one cut level, the apply entry exit edge cut level, that wouldn't have any effect. So we're going to ignore that. But we will add a overlap distance. Now, what's this going to do is when the profile operation comes around and it comes back to the start point again, you can have it go past the start point by a certain dimension to clean up that start point. You may have a witness line there, so you can just go past it by 1/4 of an inch. So let's go ahead also to we did the cut parameters, we did the cut levels, entry and exit. We did the control geometry, got our tool selected, and the feeds and speeds, we have those defined from the tool. And then we got advanced cut parameters. These options here are exactly the same as the milling module. You can add corner rounding to your corners of your profile. You can fit arcs. We already have arcs checked, so we're going to make this arc fitting tolerance. Rule of thumb, your arc fitting tolerance is 2 times your global tolerance. So we have the global tolerance set to 1,000th. So we have our arc fitting set to 2,000ths. If you can reverse engineer that, if you want your final arcs to be within 1,000th, you can set this to 1,000th and then go back over here and set that to 1/2 thousandth. You can also use cut connections. We're not going to use those. Bridges and tabs, you may want to use these to have these help have these stay connected on your sheet. If in most cases, you'll be using a vacuum table, so you really probably won't need bridges and tabs for this case, so we're going to leave those as none. And then you can form some corner rounding around the corners. We don't have any square corners on these parts, so we don't need that either. So we have also cornering parameters. You can define how the toolpath is going to look around sharp corners and also on the inner corners. We're going to leave those set to the defaults also. Sorting, you really don't need this unless you have a lot of operations in one part. We do have a few here, so we'll go ahead and set this to minimum distance. And then here is where you are going to set your parameters for the nest itself. How many of this parts do you want in the nest? So let's say, for example, we want 25 parts total. And the priority, if you set this to a priority of 1, this part will be profiled first, beginning at the lower left corner of your sheet, and then this quantity of the other part will start after these ones are already profiled. And then the fixed orientation, this means if you don't want the profile to be rotated by the 90-degree increment that we defined, you can check this box and it'll always remain fixed. We'll leave that unchecked for now. And then also you can set a grain direction for the sheet. You coordinate this direction with the grain direction in the sheet definition to keep your parts aligned in a certain direction based on the actual grain direction that you have in your material. So we have the count set to 25. Let's go ahead and generate that. So you see that we have the 2.5 axis operation for this part defined. We have a ramp entry motion for each profile, and we have our profile sorted. And we're going to go ahead and let's go to the top view again. You can go ahead and do a cut material simulation of your profile here before you go over here, but we're just going to leave it and do a cut material simulation of the entire sheet. This is pretty basic, straightforward. We don't really, typically you don't want to skip, doing your simulations, but we're going to, since the sheet is the final part that we're going to be cutting, we're going to do the simulation there. So we got this part defined as one profile. So we're going to go ahead and right click and clone this operation and make another one. and we'll open this one and we'll remove all that geometry, and we're going to select this geometry here. Right click and just generate. So we have two sets of profiling operations, one for this part and one for this part. Now we're going to go ahead and talk about, go over the nesting parameters again, just so you understand. And also this is where initially where you'll estimate your sheets and then execute your nest. So we talked about all these parameters already. Down here, if you, like I mentioned before, if you don't know how many sheets it's going to take, go ahead and pick the estimate number of sheets button, and it'll tell you that I'm going to need 2 sheets. So it'll go ahead and update the sheet count for you. And then also we're going to go ahead and execute. So it's going to calculate and think about the nest. And it was so fast I didn't see it already created my sheets. So here is our nested sheet 1. So you notice that this part was priority 1. So it started in the left bottom left corner and filled out almost all of sheet 1, and then we started on our second parts. You'll see that it rotated these parts 90 degrees to fit them on the sheet. Let's go ahead and look at sheet 2. So here is our sheet 2, and let's go ahead and do a simulation. Let's go ahead and check our preferences for simulation. We have that set to fine. We have it set to opaque. Everything looks good there. And let's go ahead and pick OK. And let's go ahead and simulate the first sheet. And we'll go ahead and turn our toolpaths off. And let's go ahead and go to the isometric view. And we'll pick play. So you see the profiles are being simulated onto the sheet. There we go. So we got all of our profiles cut. And if you look at the toolpaths, you'll see that the distance that we set is 1/4 inch from toolpath to toolpath. So if you wanted, you can tighten that up, to 0 and it would be right on it. But typically you wouldn't want to do that. A little bit of spacing between the two. You can even go tighter than 1/4 inch. And we set the outside perimeter 1/4 inch as well. So you can tighten that up if you want to also. So there's...
Hey, Don, one of the questions was, what's the advantage of using profile nesting over nesting? And this is important that you just showed. It's the entries and exits, and also the toolpath dimensions can be different from the geometry dimensions. So it is probably a good idea to use profile nesting rather than geometry nesting in those cases, if you're interested or concerned about entry exits interfering with other parts. And the other nice thing about profile nesting is because of the part orientation, if the entry exits do interfere with some other parts, only in some specific areas, you can actually go in and edit the operations themselves, the individual operations, and change it. So after the nesting is done. So if you want to expand that sheet icon in the tree, Don, that'll show them the different operations under the sheet, the nested sheets.
Oh, okay.
So these are all the operations. So each toolpath that you see in the nesting is a separate operation. So if you don't like the individual entry exits, or if you want to change just the specific behavior of a certain operation or just a few operations, you can go and edit the operations there and then control the parameters differently. So that's the nice feature of having profile nesting. Thanks, Don.
Okay. And also, I just wanted to add too, for profile nesting, you don't have to mess with your parts. You don't have to, you don't have to get all of your parts and, and make sure they're lined up and make sure they're, oriented or cut a certain way to get them nested. You just create your operation once over here, and that's all you need to do. It'll just nest that profiling operation. Okay, so we got both sheets nested. Let's just take a look at our other sheet again. Let's go ahead and simulate that. So here's our sheet 2. Now let's do some editing to the nest. Let's go to our top view again. So let's say that you might have caught on to this already, in this part right here, we have multiple sections. Now these, the inner part, the star obviously is one part, but you have sections here that are floating and not connected to this. You could go ahead and go into here and go into your, remove all of the geometry, and we could go ahead and select just this geometry. And since we're that, let's go ahead and press the control key and we will get rid of some of those. So it's the bottom, we'll get rid of that one. We'll get rid of that one. We'll get rid of that one. Get rid of that one. And get rid of that one. So we only have the star. We can go ahead and nest these separately to see if we can get, a better, tighter nest. So we're going to go ahead and everything else is going to be the same here. So we'll just go ahead and pick generate there. So what we're going to do is we're going to clone this again, and we're going to remove all these, and we're just going to select one of these and generate. So you only got one operation for this segment and then an operation for the star segment. We do need more of these, obviously, so let's go back into this cloned operation. We'll go to the nested parameters. Instead of 25, we're going to need 1, 2, 3, 4, 5. So we're going to need 125 of those to make 25 parts at the end. So we'll go ahead and pick generate there. And then what we're going to do, we made changes to operations. So the nested sheets was flagged. We'll just right click. You don't have to go back into the nesting parameters. We're just going to right click and execute the nest. And let's take a look at the sheets now. So you see here that it nested just the star segments, and then all these other segments will fit in, where it could fit them in on the sheet. Let's go look at sheet 2 and fit them in over there. In this particular case, you might have noticed that the sheet 2 wasn't filled out as much. So you may not want to do this editing the way we did it here, but it is an option if you want to break this up into separate segments. As long as the geometry is a separate, that can be defined as one profiling operation. And these we have closed geometry. It doesn't have to be closed geometry. It could be open curves if you just want to create a nested sheet of just open curves, say for stylistic purposes. If you're creating like a sheet of material that you're going to hang up on the wall with all these designs in it, you may want to use just open curves to define all those designs, and you can do that here as well. So let's see what else we got. We also have a report that you can define, and it'll tell you on sheet 1 how many of each part is defined. We have 11 of this profiling operation, 25 of those, and 12 of those on sheet 2 is the same or similar. And you can print this out. And then also, just like in any other operation, you can get information about each sheet. So it'll tell you the parameters of each sheet, how long it's going to take, and then how long it's going to take to cut the entire sheet. Now, this is entirely dependent on your feed rates that you have assigned, as well as your transfer cut feed rate for transferring from one location to another. So if you go in, just double check your feed rates, If those are correct, you can do information, and you can find out a good estimate, of how long it's going to take to cut the sheet. And then let's see what else we got on the Simulate tab. All of this is exactly the same as the milling module. All these options down here, we're displaying the toolpath. Those are all the same. Everything is the same there. So, Joe, we got any questions that we need to wrap up?
No, I think we've answered most of the questions. We'll leave it open for a few minutes. If anybody has any questions, go ahead and type them in the window. And there was one a comment about automation, and we can probably talk about using knowledge bases.
Yes. You know, anything you can do with knowledge bases in the mill module, you can do in the profile nest module as well. So you can use the knowledge bases to predefine your, if you have parts that you're going to cut out, all the time, but not, all in one day, you can go ahead and create a knowledge base of each of these operations. And then when you need to cut them again, you can just load them into your machining job. Everything's defined already, and you can just calculate the nest.
Yeah, so for those of you who are not familiar with knowledge bases are basically operations parameters saved off in a separate file. So that means if you have some certain parameters that you always use in your machining, you can save that off in a knowledge base and then just load them, so you're not changing these parameters every time you're creating an operation or a set of operations. The other thing you want to talk about, Don, is final post-processing.
Okay.
So
now,
we
go ahead.
Yeah, let me start it off and then you can finish it up. So the post-processing, obviously for profile nesting, the post-processors are very similar to the mill post-process. Actually, you get the entire set of posts that you have for milling. And in addition, of course, a lot of people are going to be using flame cutters, water jets, and things of that nature because they're cutting sheets. And we do have posts for those as well. So that's how you control what machines you're actually going to be using to cut your parts.
Let's go ahead and post one of these sheets.
Yeah, go ahead and do that. So, yeah, and the other thing that Don's showing is you don't need to post the whole thing out, so you can just post individually. And in fact, you can even post separate operations if you want. So. And on the subject of posts, in the 2022 version, we've released a very powerful Python-based post processor programmable post. Our legacy post is pretty powerful in itself, but it's got some limitations. But a lot of those have been removed. And if you wanted some special posts written, we can help you with that by writing, special Python-based posts. I mean, these would obviously be costed projects because they'll involve some of our developers to get that working. So, but then we can pretty much handle any machine on the planet today. So.
Okay, I think the only thing, excuse me, that we didn't talk about was the profile nesting preferences. Many of these are exactly the same as in your mill module. You can set all these preferences based, on your, your established operations that you do in your shop. So everything works through here is basically the same. Let's cancel there. And we'll wait just a few more minutes, see if we have any other questions.
Yeah, that's pretty much it, Don. We can wrap it up.
Okay. Well, if you guys got any questions after the fact, we'll be sending out an email with a link to this, the video for this, and you can see if we get your questions answered already in the video. If not, you can always send us an email at support@mecsoft.com.
You want to
And
bring that slide up, the last slide up?
yeah, sure. There's our support email address, and there's our phone number. And if you're new to this, you can also call our sales team, and they can answer questions as far as from a sales point of view. And then you can also chat with us on MecSoft.com. Well, that's it. You guys have a nice day, and I'm glad you could make it. Bye.
Thank you all. See you next month.
Yep.
Bye-bye.